This is a part third about advanced structure modeling. First, we talk about it's an introduction in short, and then I'll talk about in brief. Advanced structure equation modeling, we call it SAM, is a comparative statistical technique that integrate various type of models to analyze complex relationships among observed and latent variables. Here are key aspects and component of advanced SAM. Number 1, basic concept of structure equation modeling. Observed variables. What is these variables? These directly measured variables, also known as manifest variables, latent variables, variables that are not directly observed but are interfered from observed variable, also known as factors. Path arrows indicating relationship between the variables. Single-handed arrows denote causal relationship while doubling-handed arrows indicate correlation. Second type of models in structure equation modeling. These are models. Number 1, measurement models specify how latent variables are measured by the observed variables, often using confirmatory factor analysis. Structural model specify the relationship between the latent variable akin to the path analysis. Hybrid models combine measurement and the structural model, allowing for comparative analysis. Number 3, advanced techniques in structure equation modeling. Multi-group structure equation modeling compress structure equation model across different groups, for example gender, culture, to test for invariance. Longitudinal structure equation modeling analyze data collected at multiple time points to study change over time. Latent growth modeling, a type of longitudinal structure equation modeling that focus on modeling growth trajectories. Multi-level structure equation modeling accounts for data that has a nested structure, for example, student within school. Mixture structure equation modeling identifies unobserved subpopulations with the data, combining structure equation modeling with the mixture modeling. Number 4, estimate methods. Maximum likelihood, the most common method assuming multivariate normality. Robust ML adjust for non-normality and other violations of assumptions. Bayesian's estimations use Bayesian methods to parameter estimation, allowing for more flexibility and handling complex model. Model evaluation and fit indices. Chi-square test the fit of the model of the data. Non-significant chi-square suggest a good fit. Prisma root mean square error of approximation. Value less than 0.05 indicate a good fit. CFI comparative fit index and TLI Tucker's Levi's index value above 0.90 generally indicates a good fit. SRMR standardized root mean square residual values less than 0.08 suggest a good fit. If we talk about the softwares for the structure equation modeling, so these are the softwares. Number 1, Amos, user friendly, particularly good for drawing path diagram. Lasers, LIS, Liserel, one of the original structure equation modeling, powerful but has steeper learning curve. M plus, highly versatile, supported a wide range of model and complex data structure. R, Levan package, free and open source, widely used to structure equation modeling in the R programming communities. Practical considerations. Model specification correctly specify the model based on the theory and the prior research. Sample size. Large sample size generally provide more suitable estimation and more powerful deduct effect. quality data, ensuring the data is clean and meet the assumptions requirement for the structure equation modeling. Model modification, making data driven modification judiciously to improve model fit while maintaining theoretical coherence. Application areas: psychological, understanding the relationship between the psychological constructs; sociology, analyze social structure and the processes; education, assessing the impact of the educational intervention and the structural; business and marketing, studying consumer behavior and organization process. Conclusion: advanced structure equation modeling is a powerful tool for researchers across the various fields, allowing for sophisticated analysis of complex relationship among the variables. Mastery of the structure equation modeling required understanding both the theoretical foundation and the practical application of the technique. Let's talk about relationship types, mediation and moderations. We identified two basic type of relationships, co-relational and the independent. As we have seen in the model, using these relationship type, they are building blocks of our structure model. We now discuss two variations of these basic relationship, mediation and moderation. For each new relationship type of discussion will fit focus on the theoretical nature of the relationship and how it can be incorporated into our structure equation modeling. Then we discuss the process whereby we incorporate these relationships into our existing model. Mediation: in simple term, a mediation effect is created when a third variable construct intervenes between the two other related structure. To understand how the mediation effects are shown in our structure model, let us examine a model in terms of direct and indirect effects. Direct effects are the relationship linking two constructs within the single arrow. Indirect effect are those relationships that involve the square of the relationship with the at least one intervention construct involving those. In direct effect is a sequence of two more direct effects compound path, and it's represent visual by the multiple arrows. For following diagram shown both direct effect k is equal to e, this is the direct effect, and k to m between a, it's a indirect effect, and m to b is also the indirect effect. In indirect effect, k to m, m to e represent the mediation. So k to m, m to e, it's represent the mediation of the construct. M on the relationship, m on the relationship between the k and the e. Conceptual basic for mediation. For a theoretical perspective, the most common application of the mediation is explain why a relationship between the two constructs exists. We may observe a relationship between the construct, for example k and e, but not now why it exists. We can then position explain in the term of the intervening variable with the output to take the input from k and the translate them into the output e. As such, the mediation clarified or explained the relationship between the two original constructs. A simple example illustrates that point. The construct k could be a student intelligence and E could be the classroom performance. What is interesting is not just that the relationship exists between the intelligence and the classroom performance, but now how it actually works. Can we explain how students translate their intelligence into performance? We may find that sometimes a student exhibits high intelligence but does not always perform well. Moreover, some students with low intelligence score perform extremely well. So, is there some other process going on that translates student intelligence into actual classroom performance? The intervening process is the mediation effect. In this case, we could propose the construct term study effectiveness. Here we refer to the such characteristics as the ability of the students focus their efforts on their classwork, organize their class related and other activities to provide with sufficient time to complete their homework and other good studies habit. If the student is intelligent, this quality may encourage the student to study longer and the better, which could be ultimate higher classroom performance. In such case, the significant correlation between K and E would be explained by the K is equal to M is equal to E sequence. It's a mediation effect, sequence of the relationship. We could then say that study effectiveness, mediation, the relationship between the student's intelligence and the class performance. In broader terms, the concept to mediation is common. In structural models, the journal, if we view exogenous construct as the input to our model, explain the final output represented by the endogenous construct, then any construct going better. These correspondent on the theory involving at least some mediation. Hopefully, these mediation relationships are successfully in representing those mediation effect and we have good model fit. Testing for mediation. Mediation requires significant correlation among all the constructs. Theoretically, a mediation construct facilitates the relationship between the other two constructs involved. If the mediation construct completely explains the relationship between the two original constructs, that is K and E, then in term of the complete mediation. But if we find that there is still some of the relationship between K and E that is not explained, why the mediation then that denote their partial mediation. A researcher can determine if mediation exists and whether it is complete or partial in a several ways. First, if the path label C is expected to be 0 due to the mediation representing complete mediation, a structure equation model can represent mediations by including only the path A and B in the model. It would not include a path directly from K to E if the estimated model suggested the sequence K M E proof thus a good fit if would support a meditating role for M. In addition, the fit of these model could be compared with the structure equation modeling results of the model including the K is equal to E path C if the additional path HC improve fit significantly as the indicated by the X square, then the complete mediation is not supported. If the two model produce similar X square, then the mediation is supported. Because relationships are not always clear, a series of the steps can be followed to evaluate mediation. These steps apply whether using structure equation modeling or any other journal linear model approach, including multiple regression analysis using the prevention mediation diagram. The steps are: number one, establish that the necessary individual relationship have statistically significant relationship. A, K is related to E. Here we are establishing that the direct relationship does exist. K is related to M. Here we establish that mediator is related to input construct. M is related to E. Here we establish that the mediator does have relationship with the outcome construct. Estimate an initial model with only the direct effect between K and E, then estimate a second model adding in the mediating variable M and the two additional path estimates A and B. Then these ascends to the extent of the mediation as follows. If the relationship between K and E, C remains significant and the unchanged one, M is the include is the model as an additional predictor. K and M now predict E, then the mediation is not supported. If C is reduced but remains significant when M is included as the additional predictor, then the partial mediation is supported. If C is reduced to the points where is not statistically significant after M is included as the mediating construct, that fully mediation is supported. H bar illustration of mediation. The H-Bath model shows in figure 4 several mediating effects. The relationship of both exogenous construct, environmental perception, and the attitude toward the coworker with the staying intention are hypothesized to fully mediated by two endogenous construct, job satisfaction and organizational commitment. The model hypothesized that the effect of EP and AC can be fully explained through these two mediation constructs. We examine model fit and as an explanation of the overall set of the relationship and confirm the model, but we can also explicitly test for the mediation as described above. Let us examine the possibility that the relationship between EP and SI is dictated by the two construct of JS and OC. To do so, we will follow the two-step process just described. Number step 1, establish significant relationship between the construct. In this situation, we can refer to the correlation between the construct in the CFA model that analyze not performed in detail here. We can first see that EP was significantly related SI 0.56, ensuring that the direct unmediated relationship was significant. We also find the EP was significantly related to both JS 0.24 and OC 0.50, establishing on the relationship with the both significant related JS related to the both JS.23 and OC.55, those the supporting relationship between the mediation and outcome variable. Step 2, estimate the mediation model and the assess level of the mediation. In this analysis, we use the original employees rate model in figure 4, which did not estimate the direct effect from the SI. To assess the adding the direct effect would substantially change the model. We can estimate the reversed H-Butt model dotted path figure 4, which is the add of the direct path between the EP and SI. This is the figure 4. Here is no not direct effect in between this construct. Here is the mediation and modulation effect. Values represent the parameter estimated for the initial respecified direction and effect and model statistically significance at 0.5 level. The revised model with the direct relationship had a significant decrease in chi-square. As substantive improvement in model fit and the significant part estimated for the EP SI relationship seen table 4. These results suggest that there is no complete mediation but is here partial mediation. To establish partial mediation, we will need to identify a significant indirect effect leading from EP and to SI. Throughout the mediating variable, a number of potential compound paths are possible, but only 3 reflect indirect causal mediation and effect. If one of the more these indirect effect contains paths that are significant, then the model supports partial mediation. By this, we mean that there is a significant direct relationship between EP to SI, but there is also a significant indirect effect through the mediator. In the revised model, the path estimate between EP and both mediators JS and OC are still significant. Table 4. Although one mediator still has a significant relationship with SIOC is a significant. The other relationship from a mediator to JSSI become a non-significant. Does this means to there is a partial mediation? No, it just means that while S does not act as a mediator, OC can still have a mediating effect. Note that in the 3 indicates mediated effects, the non-significant relationship JSSI is only a part of the third effect. The other world indirect mediating effects still have all of the individual paths statistically significant, those the model supports the finding that OC provide partial mediation of the relationship between the EP and SI. The magnitude of the meditating effect is demonstrated by the breaking down the total effect into direct and indirect effects. Most software programs provide this decompositions of effects. However, this researcher can also calculate the effects. The interested reader is referred to the basic step happen on the website. These the websites are available where the process is the described is more detailed. Table 5 provide the breakdown effects of the EP and SI. Both original H-Butt model, no direct effect APNSI, and the revised B-Butt model, direct effects added for APNSI. As we can see in the original model, here are substantial indirect effect, those supporting the presence of meditating effect of JS and OC. The remaining question is do do those effects remain when the direct path is added and revised model? As we can see, although the direct effect do decrease, they are still significant and represent a substantial proportion of the total effect. Also note that the direct effect is significant, add considerably to the total effect and constituted the majority of the total effect, making this partial mediation situation. This is a table for testing for mediation in a but employees retention model element but employees the model and revised model direct effect. The model fit the x square is the these are the statistically significance at zero point 0.5 level. Here is a advanced structure equation modeling topic in the PLS. This is our chapter name, and the table 5 assessing the direct and indirect effect in a mediation model. This is the effect, the original model and the revised model. The values the table represent the standardized effect. The magnitude of the any individual meditating effect can be calculated using the process for the calculating indirect effect. In this is done, you will find that most of the mediation effect comes from the EPOC SI meditating relationship. Given this post hoc theoretical analysis, Ashbert need to cross validate this result with new data before the considering it's reliable. However, managerial implication for the each of the supported the hypothesis can be developed based on the overall positive result. Moderation. Let's talk about the moderation. A moderation effect occurs when the third variable construct change the relationship between the two related variables construct. For example, we would say that a relationship is moderated by the gender if we found that the relationship between the two variables direct significant between the male and female. Suppose the relationship between the two variables may be negative for male and positive for the female, or significant in one group and not the other. In this type of situation, we would need to know whether the respondents were the male or female before we could accurately estimate and interpret the relationship. We have discussed moderation in the other multivariates technique. In multiple regression, for example, there were interaction term where the regression coefficient changed based on the values of the second variable in ANOVA MANOVA. Interaction effects were used to assess whether the differences between the group were constant across the value of another variable. In both of these examples, the interaction effects are in the fact moderator. It is important to note that moderating variable must be chosen with the strong theoretical support. The assumptions of the moderator is one that cannot be tested indirectly and become potentially confound. A moderator moderator become correlated with either of the variable in the relationship, thereby therefore analyzing is of the moderator is easiest when the moderator has no significant linear relationship with either of the construct. The lack of relationship between the moderator and the other construct help distinguish moderator from the mediators. Remember that the mediator must be related to both construct in the relationship being mediated. As multicollinearity increase between the mediator and the other construct, the causal interface is called into the question, making a valid interpretation increasingly difficult. Non-metric moderators. What is the non-matrix moderators? A moderator variable can be matrix or non-matrix. Matrix and non-matrix categorical variable often are hypothesized to be moderators. These moderators typically are classification variable of some type. One common type of moderator is represents characteristics such as gender, age, or other characteristic. Differing situation or context are another type of categorical moderator. A common example would be the cross-cultural studies where the country of the original become a moderating variable. Similarly, dividing respondent into the current customer versus non-customers would be using customer status as the moderating variable. As noted earlier, theory is important is evaluating a moderator because a researcher should find some reason to expect that the moderator change a relationship. Researchers have any number of ways for the dividing the sample into the groups, but the section of the mediator should not be based on the whether it's demonstrated significant moderating effect but rather on a theoretical foundation. Once the moderating variable is selected, groups of the respondents can be defined and multi-group analysis applied. The procedure is similar to that described earlier in the discussion of the intervariance test, and the primarily interface being the moderator, and the focus is typically on the structure model estimate rather than the measurement model. Metric moderators. A moderator can also be a continuous matrix variable and evaluate using the structure equation modeling if the continuous variable can be categorized in a way that makes sense, that is the based on theory or the logic, then the group can be created on the same procedure used for non-metric moderators can be applied. For instance, if the continuous variable shows biomodality, that is the frequently distribution shows two later peak rather than one, the logic group could be created around each model. As an example, the fraction could be the measured metrically, but if there is a higher satisfied group versus a moderately satisfied group, then the two groups defined by their feelings about the satisfaction would be used as the rating variable. Cluster analysis also might be useful for from the group. However, if the another variable distribution play the clear unidimensional distribution one peak, then the grouping is not just is the possible for some factions, that is one third of the observation around the median value could be deleted, and the remaining is the increased cost, time, and efforts associated with the need of gather the sample. The advance is the that multi groups analysis can be useful to provide knowledge and the intuitive ways of the testing are demonstrating Moderation. Researcher can also model a matrix moderators by creating the terms as when using the regression approach. Using the regression terminology, then interpretant the variable can be multiple by the moderator to be created as interactions term. However, taking this approach with the multiple construct is complicated by the numerous factor. This topic is beyond the scope and the text. A brief introduction is provided on the website. This is the encourage, but all the advanced user apply the non-metric multi-groups approach unless cannot be justified. Using the multi-group structure equation modeling, moderation. What is the multi-group? And using the multi-group structure equation modeling to test meditators. Meditation. Multi-group structure equation modeling is used to test moderating effects when the moderator variable, either non-metric or metric moderator, has been transformed into the non-metric variable seen previous description. Moderation typically involves the testing of the structure model estimate, thus the process become an extension of the multi-group analysis for testing measurement invariance. As an initial step, some form of matrix invariance must be established before examining any differences in a structure model estimation. With the measurement invariance established, the structure model estimate is then assessed for the moderating by the comparison of the group model. Much like invariance testing, the first group model is the estimated with the calculation separately for the each group. This is the identical of the TF totally free models described earlier. Then the second group model is estimated where the path estimation of interest is constrained to be equal between the groups. Comparison of the differences between the model and the chi-square differences test x-square indices. If the model field decrease significantly, that is an increase the chi-square when the estimates where the constraint to be equal. A statistical significant differences between the model indicates that the path estimation were different. That is, the model fit was the significantly better than the separate path estimation were made, and the moderation does exist. If the model are not significant differently, then there is no support for moderation because the path estimates were no differences between the group. When the testing for the moderations, the researcher is looking for significant differences in the two models to support the hypothesis of the differences in the path estimates. The researcher should also examine the path estimation in the question to assess the differences in a both group model are theoretically consistent. This is the illustration of the moderation. Next video will talk about the longitudinal data.